Hi there everyone, it's me Abrar, and today I'm going to talk about different function in R that deals with normal distribution. So the functions are dnorm, qnorm and pnorm. First let me discuss about dnorm. So dnorm is a function that takes three input. The first one is x, second one is mean, and third one is standard deviation. Okay. This is the basic skeleton of this function or basic structure of this function. So if I put only x value in the norm, if I put only x value, there is no mean, there is no standard deviation, then by default it assumes that its mean equal to 0 and standard deviation equal to 1. If you put only x value, then it will show you the corresponding y value from a normal distributed curve that has mean 0 and standard deviation of 1. So if we plot this normal distributed curve or this bell-shaped curve, this will look like this. So this curve has mean 0, you see, mean 0 and standard deviation of 1. Okay. And now let us see the output of y for given x of 2 from normal distribution curve which have mean 0 and standard deviation of 1. Let's run it, and we see that the norm of 2 equal to 0.05. So if I look at here, we give the x value, that is 2, and we want to look for y value. So I can draw the point from here to here, and I can see it's nearly 0.05. Okay. So if I want to know the dnorm of 0, so that should give us value that is close to 0.04. So dnorm of 0, and it gives us the value that is very close to 0.04. Okay, so I think we get it. So we give the x value here, the x value here, and it gives us the output from a normal distribution curve that have mean 0 and standard deviation of 1. So that's the use of dnorm. This thing only happens when you give only x values. Okay, by default dnorm assumes that it have mean 0 and standard deviation of 1. But you can also give mean. Suppose I want to give mean of 10 and standard deviation of 1. And if I want to know for 0, the y value will be different. So this one is a different case. This one doesn't applicable to this curve. Now let us talk about pnorm. So pnorm is a function where it also takes the same three values, q value, or you can say x value, and a mean value, and a standard deviation value. Okay, let's comment out it because it's the skeleton of the function, but this thing, if I want to run this thing, it should give me error. So if I give only x value in pnorm, it by default, if I give only x value here and not giving any mean or standard deviation, by default it will assume mean equal to 0 and standard deviation equal to 1. So we can use this curve for explaining this pnorm. So in pnorm, what we give input in a pnorm? We normally give y value in pnorm. We normally give x value in pnorm. Suppose if I give 2, it should give me all the value up to this 2. So all this region should be given up to this 2. It will give me the percentage. So how much data I have up to this 2. So it looks like it's nearly 90 or 95%. Maximum number of data falls in this region. So if I give pnorm of 2, let's see what happened. So it shows us that it's 97% of data in this region up to this 2. So pnorm works in a cumulative fashion. It adds all the region up to this 2, and we see that it's 97% of data lies here. Okay, so if I want to know up to this point, up to 0, and we should see it should give us the value that is 50% or 0.05. So if I want to know pnorm of 0, and it says 0.5, that is this region, that is 50% of data lies in this region. So what about -2 or -1? What about -1? What about -1? It should gives us value. It looks like, let's see how much data lies up to -1. It says 15% of data, or 15% region falls in this part. Up to -1, we have 15% of data. So this that's how pnorm works. Okay. So now let's talk about qnorm. So qnorm also gets 3 values as input. Suppose x, mean, and standard deviation. So if you don't put mean and standard deviation, by default it will assume that mean is 0 and standard deviation of 1. So that's, we can also explain qnorm from this graph or from this bell-shaped curve, because it have mean of 0 and standard deviation of 1. So qnorm works exactly opposite of the pnorm. So pnorm, we give the x value, and it shows up to that point how much data lies, or how much data up to this point how much data we have. In qnorm, we give the percentage. Suppose I want to know in which point of x I have 95% of data. So if I want to know 0.95, that is, I want to know up to which value of x I have 90% of data, 95% of data. So it shows that 1.64, that is suppose this part. So up to this part, this one is 1.65, suppose 1.65, and we have 95% of data. This one gives as output 1.65. It gives us output 1.65, and we give the value that is 95. So if I want to know in which point, in which bit of y I have 50% of data. So if I want to know in which value of y, sorry, in which value of x I have 50% of data. So if I give it, it shows us in 0. So if I look at 0, and it's 50% of data in here, so it's opposite. So in pnorm, we give the x value, and it shows how much data lies up to that point. And in qnorm, we give the percentage. Suppose I want to know in which point I have 70% of data, and it gives us the x values here. So that's all the difference between dnorm, pnorm, and qnorm. Both takes 3 values. One is for x value and for mean and standard deviation. So if we don't put any mean or standard deviation value here, it automatically thinks the mean is 0 and standard deviation is 1. So another function we can talk is rnorm. So rnorm is a random number generator, and it generates number in a way so that the number follows the normal distribution. So I can generate 20 random number that follows a normal distribution curve, and I can store it in the variable named as data. Okay, so if I plot the histogram of data, I should see a normal distributed curve, and sorry, a histogram that follows a normal distributed shape. Okay, so this thing is not that much smooth or not that much perfect, but if I increase the random number, suppose 20,000, it should look a perfect histogram that follows normal distribution. So that's the use of dnorm for generating random number that follows normal distribution. So I think that's the 4 function that I have discussed, and it will erase all the confusion from us. So thank you for watching the video.